Okay, so a sample survey interviews an SRS of 267 college women. So the sample size is 267, right? Suppose that 70% of college women have been on a diet within the past 12 months. So 70% of college women, so this is the whole population. So the population proportion of college women that are on a diet, that have been on a diet in the past 12 months is 0.70, right? What is the probability? So we're trying to find the probability um, that 75% or more of the women in the sample have been on a diet. So women in the sample. So we're trying to figure out the probability that the sample proportion is at least 0.75. So this is our goal. We're trying to find the probability that the sample proportion is bigger than or equal to 0.75. So let's go ahead and do our state because we want to follow that four-step process. Okay, so we want to find the probability that uh, the sample proportion is at least 75%. So that's what we want. Let's do our plan. So with this problem, basically we're going to want to show that p hat uh, follows an approximately normal distribution, and if it follows an approximately normal distribution, then we can use the z-table in order to find this probability. So let's that's our goal. So we're trying to show that p hat is approximately normal with um, remember the mean of this variable, so the mean of p hat and the standard deviation of p hat, right? Okay, so that's what we're going after. So let's so for the mean of p hat, that just happens to be the population proportion, right? So the mu of p hat is just the population proportion, and that is 0.7. So we have that. Now for the standard deviation, we have to do a 10% condition in order to see whether or not we can calculate this standard deviation. So the 10% condition is this. We have to have little n has to be less than or equal to a tenth of big N, where big N in this case is the uh, number of college women in the population, right? All right. So that's going to be a huge number, right? So remember, our little n was 267 is less than or equal to a tenth of the number of college women in the population, which was, I think, just college women in general, right? So I think intuitively we know that this is going to be true. This number is definitely going to be less than or equal to a tenth, definitely less than a tenth of the total number of college women, right? But you can also multiply both sides by 10 to show this. So 2670 is less than or equal to. So this might be even easier to see because there are definitely more college women in the population than 2,670, right? So I think it's fair to say that this condition is satisfied. So if this condition is satisfied, we can actually calculate the standard deviation of p hat, which is just the square root of p times 1 minus p over the number in the sample size, right? So this is the square root. So remember, the population proportion was 0.7. The that means 1 minus p would be 0.3. And then n, the number in the sample size, was 267. And if you were to do this calculation, this would give you 0.028. Okay, so now, of course, we have our mean and we have our standard deviation, but we need to determine if p hat is indeed approximately normal. So we have to check normal condition. Okay, so we have to check the normal condition. So what the normal condition is just we have to have that n times p has to be bigger than or equal to 10, and n times 1 minus p has to be bigger than or equal to 10. If these two are satisfied, then we know our p hat, our sample proportion, is approximately normal. All right, so let's go ahead and do n times p. So that's 267 times 0.7. If we were to do that calculation, that would give us 186.9. And we know that is bigger than or equal to 10. So that one's satisfied. So now let's check out the other one. So the other one is 267 times 1 minus p would be 0.3. And if we did this calculation, that would give us 80.1. And of course, 80.1 is definitely bigger than 10. So we know the normal condition is satisfied. So this does, in fact, imply that p hat, the sample proportion, this variable, is approximately normal, with our mean for this variable to be 0.7, right? So 0.7, and our standard deviation was 0.028. All right. So now that we have this, we can actually relatively easily do this computation, the probability that p hat is bigger than or equal to 0.75. So now the do part of our four-step process. Okay, so we're going to do the probability that p hat is bigger than or equal to 0.75. All right, so this is, so we need to standardize this. Since it's approximately normal, we can standardize it. So that's probability that z is bigger than or equal to, so it's 0.75 minus the mean, so 0.7, all over 0.028. Okay, so if we were to do that calculation, that's equal to the probability of z being bigger than or equal to 1.79. Okay. All right, so going to our z table, notice we want the area that's less than z, right? Less than or equal to z. So here, we actually need to rewrite this where it's 1 minus the probability of z less than 1.79. And now we can use our z table, right? Because it's z less than. So less than 1.7, so 1.7, and then 1.79, so 9, right? So we can see that it's going to be that 0.9633. So we know this is equal to 1 minus 0.9633, and that is going to be 0.0367. All right, so the probability that the sample proportion is bigger than 0.75 is about 3.67%, right? So conclude. Okay, so about 3.67% of all SRS of, let's go down a little, of size 267 will give a sample proportion that is 75% or greater. Right, and this makes sense. So this is telling us that the probability that the sample proportion is going to be bigger than 0.75 is about 3.67%. Well, think about it. If the population proportion that women are on this diet is zero point 0.7, then the probability that a specific sample with 267 people is going to be bigger than 0.75 is going to be small, right? That probability is going to be really small. So this does make sense with the context of the problem.